Hello, everyone. Today we're going to solve the LeetCode question, remove duplicates from sorted arrays, or from a sorted array. So in this instance, we're going to be given a sorted array. And what we want to do is we want to be able to remove the instances where they're duplicates. So for example, here we see the values 1, 1, 2, and our end result should be 1, 2. And then, so we're essentially going to change this array in place. So we want to make sure that this 2, right, this next distinct value gets placed in this current value. And then you could notice like these underscores. This just notates that we don't really care where the rest of the values go. We just want to make sure that the distinct values are first, and we can do whatever we want with the rest of the values. It'll make more sense with this example. Say, for example, we have these values 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. You could notice that the distinct values are going to be 0, 1, 2, 3, 4. So that's easy enough. But we'll and then for the remaining underscores, those are all the duplicates. We don't care what order those are in. They can be in any order. It doesn't really matter about what happens to them. We just care that these are in the correct position. And what we also want to do is we also want to find out how many distinct values we had. So in this case, notice for the first problem, we not only want to change the array in place, we also want to return how many distinct values there were, which is 2 in this case. And then in this instance, there were 5 distinct values, so we also want to return the value 5. That's why if you notice our function, we're going to return an int, which is going to return the number of distinct values. And then we're also going to update this vector of ints, which in place. So nums is a list of integers, and we're going to go ahead and once again put the distinct values in order at the front of the list. Some constraints to consider are that this can be a very, very long list. We're capped at the element values from -100 to 100. And then, of course, the list that we're given is in ascending order, which is very important. So that's really it. If we were to read this, it would be kind of a little bit lengty. So I kind of didn't want to go through that. You're welcome to go ahead and pause the video and go ahead and read this. I just don't want to make it confusing. But that being said, there is another constraint that I want to specify, and that's do not allocate extra space for another array. Because if we were to use another array, this problem would be very simple, right? So if we were to use space complexity big O of n, then we could essentially just iterate through this list, and whenever there's a distinct value, right, however we choose to define that, then we could just stick it into a separate array or push it back into a separate array, and then go ahead and iterate. Once we're finished, we just iterate through that separate array and then put them at the beginning of this array. And we could also return the size of the distinct values array. So it makes the problem really trivial if we do it that way. But if we update the array in place and we use no additional, so we're not using any additional memory, then that's where it becomes a little bit trickier. And we also want to do it in of O of n time. So we just want to be able to go through those values once. So actually, I should probably list that as something that we're going to do. So we want to do it as time complexity big O of n, and then space complexity, just a constant time. So O of 1, there we go. That's really it. That's what this approach is going to be like. So how do we get this done? First few things. We're going to assume that the rule of thumb in this approach is, or how we define what a distinct value is it's going to be the last of its kind. So that's going to be considered distinct. So what do I mean by that? The last of its kind is, so we notice that we have 2 zeros here. The last of its kind in this instance is this 0. So this is considered the distinct value, 0. There's 3 ones here. Which one is considered distinct? Is it the first one, second one? No, it's always the last of its kind. For the 2s, it's going to be the last of its kind. For the 3s, it's going to be this one because it's, sorry, this one right here because it's the last of its kind. And for the 4, when there's only one value, it's just itself, right? It's the first value and it's the last value. So that's going to be this distinct value. So that's really one thing to kind of be mindful of. It's always going to be the last value, or the last of its kind that's distinct. So our steps are going to be the following. Number one, we want to keep track of how many distinct values we have. Initially, we're going to go ahead and set it to 0 because we've assumed we've found none. We haven't started iterating through our list, so there's none. The next thing is we want to iterate through the list from the beginning one to one before the end. So start at the beginning of the list and then continue, but do not include the last element. There's a specific reason we do not include the last element, and that's because with this approach, if you include the last element, you're going to get an out of bounds array error. So make sure to only start from beginning, so index 0 all the way to less than size -1. Okay, so we'll see that implemented in just a sec. Then what we're going to do in step 3 is for each iteration, we want to compare the current value or the current element with the next element. We want to compare the current elements that we're on. So you can imagine this one with its buddy that's ahead of it. So we want to compare these two. And then the next time we'll compare these two, the next time we'll compare these two, and so forth and so forth. You could see why we want to stop one short, because this is the last pair of buddies that we want to compare. There's no one after this 4 to compare with, so that's why we don't want to include that last value. And there's going to be a special kind of edge case for that we'll consider. So what we want to do with that comparison is, if we find that the current value and the next value, that they differ, then we know we found a distinct value. And this is just by virtue from them being sorted. Just because we know that in this case, the current value and the next value, these are the same. So we know this is not the distinct value. But in this instance, the current value and the next value are different. So this is the distinct value. See, so according to this approach, the last of its kind is the distinct value. So next up, what do we do once we find the distinct value? So the distinct value must be placed at the correct index. So once I find that this is the correct, this is the distinct value that I want, what I'm going to do is I'm going to put it in the correct spot. So this 0 should be at the beginning. So we're going to go ahead and move this over to this location. And then we also want to increment our distinct values count, because we know that we just found one. So we continue to do this until we get to the end of our loop. And then at the very end, so once we're done, so you can imagine, as I'm kind of going through this process, this 0 is going to be placed here. This 1 would be placed at this location. The 2 would be placed at this location. So each time we find a distinct value, we put it in the correct spot. Once that's all said and done, the last value is always going to be distinct. According to our approach, the last value is always going to be distinct, even if there's repeating, because remember, we said the last of its kind is always distinct. So what do we need to do? We kind of have to have like a little edge case scenario there. And that's that what we're going to do is, for the last value, we always consider it distinct. We always place it in the right index, and then we increment the count. So exactly like we did before when we found distinct values. That's pretty much it. It's going to make more sense when we look at this example test case, but that's kind of the logic. I definitely recommend reviewing this test case with me. We're going to go through this together. And once we do, if you still don't feel clear, I'd recommend kind of rewinding back to this explanation that we did earlier, and it's going to make a lot more sense after you see that. So let's go ahead and look at this example test case right here. So we have our current and we have our next value. So we're starting right from the beginning. And what we're going to do is we're going to check, are they different values? No, right? They're the same value. So we don't care. We don't do anything in this instance. Now, in this instance, the current and the next, they are different values. So I know that I want to go ahead and place this 0 into the index where distinct is. So what we're going to do is we're going to put this 0 at index distinct. So you can imagine I kind of transferred this 0 here. I know that it's still 0, so it doesn't really look like it. So you can imagine I'm erasing this 0 and putting back the 0. And then we're going to increment our count. Okay, so now that iteration is done. Let's go to our next iteration. Are they different? Is the current value and the next value different? Nope. So let's go ahead and continue. Is the current value and the next value different? Nope, they're not. So we're going to go ahead and continue. Is the current value and the next value different? Yes. So in this instance, we found another distinct value, which is this one. So what we're going to do is we're going to grab this value and we're going to put it at index 1, right? Because that's where this distinct value not only keeps track of how many distinct values we found, but we're also using it as an index to see where to place our next distinct value. So this 1 is going to be placed right here. Remember, the rest of the values, we don't really care how they kind of end up. We just want to make sure our distinct values get placed in the right location. Okay, so now that we finished this iteration, oh, actually, I forgot to increment my count. Now that we finished this iteration, let's go ahead and continue. So are these two values are different? No, they're not different, so we can just continue. Are these two values different? Yes. So we found the next distinct value 2. We're going to put it at index 2. So the 2 is going to be put at index 2, which is going to be right here. There we go. And we're going to increment our count. Let's go ahead and go to the next case, just because we finished our iteration. Are these different values? Nope, they're not different values. Are these different values? Yes. So we found our last, well, not our last distinct value, but our last distinct value for this loop. Remember, we stopped short of the end. We don't consider the 4 yet. So for here, we're going to go ahead and put this 3 at index 3. And then we're going to go ahead and increment our count. So far we found these 4 distinct values. Now what we're going to do is we finished our loop. It's pretty much done. We're just going to go to step 4, which is specific to the last case. So the value 4 is going to be counted as distinct. So it's going to be put in this index 4. And we're going to go ahead and increment our count. So notice here our distinct count is 5, which is correct. And we have our first 5 distinct elements right at the beginning. And that's exactly what it's looking for. So I hope that made sense. Please make sure to rewatch this if necessary. It definitely takes some time for it to kind of like marinate within the brain. So take as long as you need to review that. And let's go ahead and continue now with the coding sessions once you feel comfortable with continuing. So what do we want to do? We want to first set up our distinct values count. And once again, here, we haven't really found any distinct values. So that's why we're going to go ahead and set it to 0. Next up is we want to iterate through the list from beginning to 1 before the end. So we know that, let's say our index is going to start off at the beginning. And we know we're going to continue not until less than size, because that would continue to the very last element. So we want to do less than size minus 1. It's very important to be mindful of your boundary conditions. And then we're going to go ahead and increment 1 at a time. There we go. What we also want to do is, just for the sake of, actually, let me go ahead and comment this first. So iterate from beginning to 1 before the end value. And then this is just because we are going to compare the current and next. And speaking of current and next elements, this way, so we can kind of refer to these values. So current elements and next elements. Let's go ahead and set up temporary variables for them, just so that it makes it a little bit cleaner. So we know that the current element is really just going to be nums at the current index. And we know that the next element is going to be nums at the current index plus 1, right? So the buddy next door. And so now that we kind of have that set up, what do we care about these two? We care about these two when they're different values, because that's when we know it's a distinct value. So let's go ahead and set up that condition. So if the current element is not equal to the next element, then what does this mean? We know that we found the last of its kind, aka distinct elements. So in those instances, we want to do a few things. We want to, number 1, place the current distinct element in the correct location. And then we also want to increment the distinct count. Okay, so let's set that up. So what we're going to do is within our vector, we're going to go ahead and use the distinct values to say that for the first value, we're going to go ahead and set it at index 0, so that this makes sense. And what are we setting? We're setting the current value at that, or we're setting the current value to overwrite that element value. So essentially, we want to make sure that the distinct value that we found is placed in the correct position. We also want to make sure after we're done with that, now that we've used it as kind of like an index, we want to go ahead and increase its count because we just found a distinct value. So that's really kind of the most complex that it gets. It's not too much, but that's really it. This is going to repeat until you get to 1 before the end, right? So we're going to go ahead and exit in this example at this last 3. Now there's always going to be that edge case where we have the last value. The last value, last elements, or last value, I should say, of the list is always distinct in this approach. So we, once again, have to put it in the correct location and then increment the distinct count. So we actually, I'm just going to go ahead and copy this so we see that. So we place the distinct element in the correct location and increment its count. Yeah. So how do we do that? Let's go ahead and set nums at, once again, the correct location. And what is it? It's going to be the last value. So the last value is, well, we can go ahead and set up our last value by saying nums.size -1. There we go. So this is going to be our last value, and we're going to go ahead and put it in the appropriate location. And we're going to increment our values count because that's another one that we just found. And so just like that, this is responsible for updating our values in place so that this array gets sorted. And then the distinct values is constantly incremented inside of here. And then it's going to be finally incremented here to keep track of how many distinct values we've had. So remember, we need to return the number of distinct values. So let's go ahead and return that as well. Let's go ahead and run it. And let's see if I made any syntax errors. Yes. Let's see. Let's look at line 31. Oh, no, sorry. My mistake. There we go. I have to be within the scope of the function in order for it to work. But let's go ahead and look at that. Line 32. Oh, nums.size. And let's see, nums, distinct values. Did I say something wrong? Oh, current elements. There we go. Got to kind of be mindful of these things. Whenever I'm light coding, it's kind of fun, but it's also I feel like I'm thinking about a few different things at a time. So sometimes these kind of things slip away, but I hope that's okay. So this works. Let's go ahead and submit the solution, and should be looking good. There we go. Looks good. So I hope that this made sense. I feel like this is a pretty good problem to go over. And also keep in mind that there are other ways to solve it, but this is kind of a preferred method in the sense that we're not using extra memory. And then the time complexity is as fast as we can get it, which is a big O of n. So thank you so much for watching. I really appreciated your time. Please like, share, and subscribe if you haven't already done so. I'm going to go ahead and try and post several of these videos a week, perhaps not daily, just because it's kind of difficult. But I'm going to keep posting as much as I can. Thank you so much, and I hope to see you soon.